use Slido. The email code is 589609, and please type your questions. We will take them after presentations. And sorry for the echo during the presentation of Opava. Now we will move to Brno, and it will be Mr. Petr Baxant, who is an associate professor at the Brno University of Technology. He is a scientist engaged in lighting research, light measurement, and luminance analysis. And he's also interested in nature protection and the impacts of human activity on the environment. So Petr, the floor is yours. Please, 15 or 20 minutes time.
So thank you, Anna. Thank you all for this time, for sharing our research and development, what we do in lighting technology, especially in measurement area. And I'd like to present now our decision or our solutions from special experiment which was done in Brno before a month about. So in this brief presentation, I'd like to introduce you how we measure Alan as an artificial light at night. I hope the presentation is visible.
Yes, it is.
Yeah, okay, so I will try. Let's start to a little bit introduce how we can see on the light in the night in a natural condition. Here on this slide, I prepared a natural source of the light in the traditional sky, represented by full moon. This slides or this picture shows how the moon can look through the luminance camera and analyze the luminance distributed on the surface of the moon, and what's the level of the luminance on this sky object is, and what's the illuminance caused on the surface on the Earth. So in natural condition, the major source of light, or maybe one of the source of light in a night, is just only moon, which reflects the sunlight. The ratio between the full moon and the full sunny day is bigger than, if we compare the ratios of illuminance, is bigger than 1 to 1 million. So in this dynamic, change the day and night, and how we can see on this picture and average luminance on the moon, we can measure these levels around thousands of candela per square meter, and it depends on the position of the moon on the sky. For example, in this case was average luminance 3,418 candelas per square meter, and in this condition the same full moon but in a different position was just only 2,777 candela per square meter. And in comparison, in the below the picture, there are small candles and flames of the candles to compare in a similar scale of luminances, how these small sources, also we can say the nature sources, just only flame with a similar spectrum and intensity compare to the moon. As we can see, the luminances are very similar, not different in a range, but the intensities, when we calculate all the intensities together and compare to the moon, we can say that the moon shine more than 30 billion times higher intensity to the Earth, but of course the distance of the moon is much higher. So this is just only for condition how the nature source can look, and now to our experiment in Brno. Or maybe we can start 20 years before, when we was in some experiment which was done in Liberec district, where organizers, Czech Lighting Society and regional municipalities prepare for us conditions to measure affects light or affect nature or affect sky luminance during the public light off. And on this picture there are displayed visible image and luminance map, how it looks, how the sky looks during the public lights on, and when the public lights was switched off. So it was before 20 years, and with techniques and devices which we had in this time. But after this time, we improve our measurement, improve the sensitivity, improve the precision and uncertainty of our devices. And we can repeat similar, but maybe smaller for measurement task or experiment in Brno with cooperation with Brno City Municipality and technical network of Brno. And these utilities help us to realize the public lighting switching off, and we can measure how the public light affects the luminances of the sky or of the surrounding, and observation from the concrete point of the Brno. We select a point especially around the Brno Planetary and Observatory, where the quite darkened environment, and from where we can observe the Brno in good view. And in this picture, concrete in this picture, we can see on the Spilberk castle how it looks when the lights, public lights, is off. And in this time was switched off 42,000 of lamps in the Brno. Intensities or luminances of this surfaces of the facade and of the surrounding trees and hills are below the tens of candle per square meter in the blue part of the scale. And you can see that also the sky is quite dark, and no lights disturb the viewing. When we switch lights on, we can obtain this image, and you can see the difference between the pictures when the architectonical lights shine on the facade, of course, and also the public lights down the hill and the castle is shining on the surrounding nature, especially on the trees. You can see there is a trees without leaves in this moment, and also the buildings are shined here by the public lights, and the intensities or luminances increase to levels of 0.1 or 0.5 about. So this is the first objective measurement, how we can compare very precisely data from the public lighting off and public lighting on. So it is on the concrete view, very precise lens and camera with high resolution. In next slide, I'd like to show you the FishEye view to the city center from the same point. During the example or during this experiment, also the plane from the air scanned the surface of the Brno from the plane camera. And here on the image you can see the line which were created by the plane flying on the long exposition of this picture. So it's just only for notes. And the luminance image here shows how the city looks during the experiment when the public lights are off. And the next slide is the switch on. So also the exchange of the lights or exchange of the luminance map during the switch on and switch off. And then we can compare on the same scale of luminance how the public lights affects the night surrounding. But here you can see that not all the lights is generated by public lighting. There is a lot of lights rests after the public lights off. So not all light pollution came from the public lighting. The similar situation is if we see on the zenit, if we see above head directly to the sky, and in this image, in this luminance map, is shown how the sky looks during the public lights off and when we switch it on. So the sky dome luminance increasing, but in this scale the difference is not so obvious. But if we calculate it to the number, we can find some portion ratio between the switch on and off, and increasing of the luminance of the sky. Maybe better is in other scale. If we change the limits, for example, here is the limits 10 candela per square meter, and we decrease it to just only 0.05 candle per square meter, and exchange to logarithmic representation to highlights horizontal light. And also we can compare the situation when the public light is on and public light is off. So there is obvious difference between the lights on and lights off. And also we can obtain from this the numbers. For this case, we prepare some detection objects. In this case, we use a circle, simple conus in center in camera lens, and angle from the zenith about 60 degrees to each side. So it means 120 degrees conus in this inner circle, and outer conus represents the angle 178 degrees. Not full 180, but 178 degrees, because the last one degree or 2 degrees make some errors around the boundaries. So in these circles we can count all the pixels, all the points, and make some average number or average luminance in this spheric angle, and can be expressed by these numbers. So in the inner circle is just only 0.0039 candle per square meter, and if we use the bigger circle, we can measure this number, or this luminance 0.0060 candle per square meter. It looks like very small luminances against to the luminances of moon. We have fortune that the moon in this case was really in the dark. and the moon didn't affect our measurement. So it was very nice situation in this case that we can measure just only the sky without the moon affection, just with the public lights. So the constellation was very, very good. If we compare it with the public lights in off state, it's also visible different between the numbers, and so represented average of luminance inside the circles, and compare how this public lights affects the luminance of the sky. So this number represents really true reality, or how to say, objective reality in visible scale, in photometrical values. I must say that these values are really close to photometrical representation of values, how we measure it in standard of visual system based on standards of CIE from 1931 for a normal photometrical observer, not in other type of spectrum. This camera is calibrated to the photometrical standard and photometrical observer. So these numbers are really true and with higher accuracy measurement for this case. Also, we can separate from this number illuminances caused by this luminance of the sky, and this is in this conclusion, and I'm near to the end of the presentation. If we compare the circle radius 60 degrees from zenith and public light off and on, we can separate the numbers of illuminance, which are really very low, and also the luminances in candle per square meter, and can compare the increment when we exchange the public light from off to on. So the luminance and also illuminance increase about 79 or 80% to higher. And if we switch off the lights, so it means the decrement from on to off, we can save about 44% of luminance or illuminance. If we will calculate with the higher or bigger circle, which is 89 degrees from zenith, we can obtain the similar numbers, not very different. This is a similar with a smaller circle and a bigger circle. So the number increment from state off and state on public light is 77% to increment, or 43.6% if we switch off the light. So we can say that we still have a big reserve in saving of light in probably some private sector, with the advertisement shops, maybe some parking states or buildings and so on. So I can say that we are on the beginning of Alan measurement, and from this experiment we can say that we have devices how to do it, but we must find or looking for a proper method how to visualize a very wide range of light scenery, because it's not very easy to compare the pictures or images in a different lighting condition with a very wide range of luminances, because these numbers are very small, and in a real situation, in a scenario, there is sources with luminances higher than maybe 100,000 of candle per square meter, and the visualization is very complicated. We must find any realistic indicator how to quantify or qualify artificial light at night. We were looking for this indicator, which can be maybe similar like indicator UGR for disturbing glare. It is necessary to develop new devices for very sensitive and fast scanning directly from the street terrain. We want to start some terrain scanning and make some database of terrain measurement in Czech Republic, minimally around the Brno, and I'd like to visit many other interesting places in a Czech Republic and try to scan with our devices the situation in a night condition. And actually it's quite long and complicated express proper data from the night sky and night environment. And we are working on the improvement, and our mission is help to the scientists have an objective data about the light and at night, not only in a visual spectrum, because I think the visual spectrum, it's not the target of our measurement, and we must also focus in other type of spectrum, especially to melanopsin sensitivity and how to say, affection of circadian rhythm, not only humans, but of course of plants and other species in a night environment. So the spectrum sensitivity of the devices should be changed to the spectrum sensitivity of concrete species or organism in an environment. So this is maybe something for thinking what we are missing. If we use public lights, there is some animation how the Milky Way can look from the Jackson Lake, and how we put the part of the picture from the observatory Izerska region to this picture, how the luminance of the sky looks against to the luminance originally in Jackson Lake, where the affection of public light isn't. So this picture from author Petr Horálek, and I try to compare this type or these two images from original to the Czech Republic condition. This is our team of researchers in Brno University of Technology, where we work together with our colleagues and still working on improvement of our technology and help to scientists to find objective data from the environment. And in the last slide, I'd like to thank all our partners, especially Brno City Municipality and Technical Networks, and maybe also director of Brno Observatory and Planetarium for help and support of our working and make this experiment maybe also in the future. And also I'd like to thank to all this in this seminary. Thank you.
Thank you, Petr. Thank you for your presentation, and thank you for showing us the outputs or outcomes of your experiment, which shows that not only our focus on public lighting is enough, but we have to tackle all the sources of disturbant light or sources of light pollution. And thank you also for pointing out that for future work in the field of lighting, we have to also take into account the spectrum sensitivity not only of a human but also of other species that we affect by our light during the night. So I would repeat, if you have any question, please type them in the Slido, and we will move